Our next speaker is Dan Dicaire, also with the City of Ottawa. Dan is a PEng and a certified energy manager who works for Ottawa Community Housing. He's the manager of energy and sustainability. Over the past 12 years, he has coordinated the installation of over 625 kilowatt of solar arrays on 37 different OCH sites and managed a portfolio-wide LED lighting retrofit, which will save over 4.6 gigawatts per hour of electricity annually. He supported OCH's development team to produce Ontario's first mixed-use passive house at 1290 Coldry and is currently part of OCH's development team, which is building Canada's largest passive solar, largest passive house building at 811 Gladstone, as well as another 1,000 units worth of passive house, low, mid, and high rise. He's also developing the zero GHG retrofit strategy for OCH's 15,000 units, which started with the Presslin Net Zero retrofit. He is a proud father of a lovely 7-year-old daughter, and I thought I was busy.
Happy International Women's Day. It's fantastic. And I love following Janice because I really enjoy the very stark reality that she put for us. And we cannot forget those first slides of hers because we have a very large challenge ahead of us. Hopefully, I'm going to help show a piece of it, but there's a lot of work to do, and it's very exciting to be here. So today, hopefully, we're going to go through some tools for carbon neutral deep energy retrofits. So hi, I'm Dan Dicaire. I'm manager of conservation at Ottawa Community Housing, and I've got probably about 15 years of background in different types of energy industry and building sciences. Today, what I'm hoping to do is give a little bit of context on the current housing context, what it looks like for a housing provider like Ottawa Community Housing, and then how we're hoping to tackle that very large challenge by showing you our pilot, the Presslin Net Zero Energy Retrofit. And then we're going to go through some of the deep retrofit tools that we've kind of developed as we did that pilot and how we're hoping to expand it to the rest of our portfolio. And really, we're trying to inspire everybody to champion deep energy retrofits in our communities, whether it's here in Ottawa or throughout Canada. So how I spend my days, I spend it at Ottawa Community Housing. We manage 15,000 units of social housing in buildings that are over 60 years old in about 160 different communities or high-rise buildings. That's about 17 million square feet of real estate in Ottawa. And that 17 million square feet consumes about $25 million of utilities every single year in terms of water, natural gas, and electricity. Now, today, for the past 12 years, my job has been to try and minimize that number as much as possible, keep it as constant. In all honesty, we've done a fairly good job of what I call the low-hanging fruit, the easy business cases, if you will. Some of those are on screen now. I love this picture. It's one of our project managers standing on top of 3,000 toilet seats. We changed every single toilet in Ottawa Community Housing to a low-flow toilet. We've done LED lighting retrofits, changed about 30,000 LED fluorescents. Then we've also installed lots of renewables. So that's, we've got, like we mentioned, 625 kilowatts, and we're on track to have a megawatt of generation within urban boundaries by about 2024, 2025. And that saved us about just under $60 million over the past 12 years in terms of utilities or its generated revenue. But in all honesty, we need to do more because the next stage of this looks different and it's going to be a lot more challenging. I'm stealing this slide from Janice, and maybe this one is a little bit out of date, but the thesis is the same. We are now in this climate crisis. We've got these very old buildings. In fact, that existing buildings percentage, we might even make up a little bit more because we've got such old buildings, but we also play a role in all of these other sectors. And today, we now have to look forward, say, okay, we've been managing these buildings, but now we need to manage them in an energy transition. How do we not only meet the capital needs, which you can imagine are large in terms of a 60-year-old or over 60-year-old portfolio, but also take those life cycle opportunities to transform them to being zero GHGs. We've got about 27,000 tons of CO2 that we emit every year, and over 90% of that comes directly from natural gas emissions. The way that we're doing that is going to be something like the Presslin Net Zero prefabricated retrofit that we did. So this is the Presslin site. Before the retrofit, it's 4 units, townhomes. We literally have this exact template of building all the way down the street on Prince Albert and Queen Mary. We got about 500 of these units down there. And this particular block spends about $7,200 annually on utilities and emitted about 18 tons of CO2 every single year. Now, perfect on the other screen. Post retrofit, we've got a net zero energy building, and it now emits 0 tons of CO2 annually. And that entire retrofit was done while the tenants were in the units. Because as we mentioned before, we've got a little bit of this housing crisis that's taking place. We don't have extra units to move these tenants out in order to do this work. And this work is desperately needed so that we don't fall into disrepair on these 6-year-old buildings. Now, the question, what does this look like? All right, thank you for bearing with me. This is 197 to 203 Presslin. Like I mentioned, 4 units, 2 stories. We dug all the way down to the foundation, basically exposing that footing in order to be able to replace the old weeping tile, but that also gives us access to the foundation, where we're now able to waterproof as well as put an air barrier to make sure that we've got a completely covered foundation. We then put 8 inches of insulation on the exterior, brought that all the way up above grade. And then what we're doing right now is putting holes in the siding so that we're able to put a beam all the way around the foundation in order to support our above grade panels. So above grade, we're making these super 9 by 20 foot panels out of SIP. So structurally insulated panels, 8 inches of insulation sandwiched between 2 sheets of OSB. We're stitching all these things together to make super panels that have the windows and the doors already cut out, but we're also trying to finish them as much as possible. So you see us putting the membrane, the strapping, as well as the siding all onto one. We're making about 24 of these that we can then handle and bring to the site in order to install them onto the actual siding. So we've got a complete new building facade, and in all, we installed about 8 panels in 1 day using this method. So you can imagine it goes a little bit quicker. This gives us a brand new building envelope all the way around the foundation, all the way around the building. That means that we can go into the basement, remove the natural gas equipment, and install heat pumps, both for domestic hot water as well as heating and cooling. When we get to the rooftop, we've kept that air barrier membrane going all the way to the top. We put it across the existing roof, and we add an extra roof on top to accommodate the additional about 16 inches of insulation that we need on top of that roof in order to increase the U value. Now, that new roof gives us this beautiful pitch on the side of the exposure to put 34.8 kilowatts of solar on that roof. So now, when you take it all together, we've added this building envelope that's reduced the overall energy consumption. We've replaced the mechanical system with some high efficiency mechanical, and the small amount of energy that we still need is going to be generated by those solar panels that are on the southern exposure. When you put all that together, that gives us our net zero rating on the energy guide. So that was all theoretical. So how do we do? Well, this is our pre-retrofit energy model. So about 118,000 kilowatt hour equivalents, because we're converting natural gas into electricity. So the results, which we confirmed in by the end of August 2022, our post-retrofit measured consumption was 40,892 kilowatt hours, and our PV generation was 40,847. Just 45 kilowatts that we're missing, but in all honesty, that is a rounding error considering the tools that we use. So effectively, we've got ourselves a net zero retrofit of this building. So now let's look at some of the energy, the tools in order to get this and scale it up, because really one project is not going to get us anywhere, and that's one of the biggest messages. The first thing from a technical point of view, we're going to go through some technical here, but this is the exact same stuff that Energy Sprong. It's the NRFit retrofit guide. It's the same as Passive House. We're trying to get those same levels of performance and be very useful tool. So we did all of this work with Natural Resources Canada, both on the research side as well as on the funding side. They have developed the NRCan's prefabricated exterior energy retrofit guide, which is helping, which the concept of it is to give you that recipe book. Everything I just showed you was done by OCH's trades. It's not rocket science. It's not that, it's just you need to plan it out. So I assure you that the technology and the expertise to do this type of work exists right now, although 100% appreciate the workforce is a little bit stressed right now. And there's also the 2 new programs that got launched by NRCan in terms of the Greener Neighborhoods pilot program and the Deep Retrofit Accelerator Initiative. they are designed. In fact, the Greener Neighborhoods program mentions our project on their website because they're trying to get other areas to aggregate to facilitate this type of retrofit. And like I said, it's not rocket science for experienced architects, engineers, and contractors. You just got to have some of that willpower to get it done. And here's, if people are looking for some of the technicals, we basically increase the U value up to 60 in the attic, around 30 to 40 in the walls. You got to improve that air tightness by about 75%. So we took it down from just under 8 to around 2. And you're replacing all that natural gas equipment with heat pump technology, and then your renewables on top of that in order to round everything off. You got to look at it as you're putting basically putting a sweater on that house. You're going to cut off your eaves and you're going to just wrap it up in a nice new building envelope all the way down to the footings, all the way up to the top. You got to do something in order to make sure that you've got continuous air barrier, both below grade as well as above grade. So that below grade membrane needs to tie into your above grade panel, and then it needs to reach up to the next level. And then you need to go over your existing roof. And I mean, you can do this in a lot of different ways. Maybe you take down your roof and you put a whole new membrane. Maybe you're taking down a facade and you're doing this, but you got to have that continuous air barrier and that increased insulation in your mind as you're doing that. And hopefully you're going to be able to get some amount of renewable on that site as well. This site, I will admit, was very perfectly sited in terms of getting a beautiful southern exposure. And then obviously you're going to be able to take out that old mechanical, put in your heat pump or your electrification technology, and you're going to need some amount of electrical upgrade in order to be able to not only take into account these new electrical loads, because you're literally what's currently being fed by a natural gas pipeline now needs to come through your electrical service. So there's definitely some upgrading that needs to take place, but also you're going to need to account for some amount of generation if you are in fact trying to go for the net zero aspect and really eliminate all those GHGs. And that's what, when we add all that up, we're able to get that zero Energide rating. So we've talked about decarbonizing on the operational side. 100%, we need to talk about the embodied side. And we don't have that full analysis, but we do have it for the wall assembly. So what we have here is basically the Presslin project is in orange, or that grayish orange, and it shows what we actually did. So that is literally our roof and our windows and our cladding. This is how much embodied carbon exists in them. And then it compares it to, you know what? There's probably better methods to what we did. And here's what could be a best in class. So overall, our total embodied carbon, about 36 tons. But yeah, it could probably have been somewhere closer to 14. But regardless, for this particular project, when we consider that we're now eliminating 18 tons every single year, that definitely, it plays very well in terms of the embodied energy for the wall assembly. Fully appreciate. We're talking about also adding renewables on top. So we do have to add some years in terms of your carbon payback for the solar panels. We've got to add some years in terms of that mechanical system, and there's further analysis that needs to take place. But we feel very confident that we are in the under 10-year payback when it comes to a carbon payback. And just another tool for us there, if you are interested in doing that kind of analysis, please have a look at Natural Resources Canada's Material Carbon Emissions Estimator. This is a tool that they're developing, that they want this type of analysis to be done more and more often, so that we start realizing it's not just about the operational carbon, it's also about the embodied carbon. The next tool in our toolbox, something about finances. Hey, that was a great video. How much does it cost? 100% the first question I always get. And I will, so keeping in mind that this was done during the pandemic. By the way, we started in May 2020, all of that work you just saw. And that obviously it's also a pilot, but this was over $1 million to be able to do this retrofit. So yes, that is a lot. That when you say, oh my God, that's, $250,000 per unit. If you're looking at doing this kind of thing, what I did put up here is basically a breakdown of what areas where the money got spent. So we spent about a quarter of that money went on to building envelope. Another about quarter of it went on electrical and mechanical. Then our consultants and our contractors are going to take up that other half of that pie, if you will, depending. And I do think that some of these can be made more efficient and shrink the pie a little bit. There's definitely some grants and incentives and partnerships in order to make that a better reality, right? There's lots of different programs out there, and we are talking about some of them today in order to try and make this a reality. But the more important thing that I want people to remember is not how much did this cost? It's how much is it costing you? Because what the question that people don't ask when they say, oh, how much was that really expensive retrofit is, wait a minute, how much is this building going to cost me regardless? Because that's an analysis that's not often done. And we need to start doing more of these total cost of building ownership studies. And that's a much more useful financial tool that I'd like to share with you. Because that same building, that status quo, this is its net present value in terms of what we were going to spend on it, regardless for the next 60 years if we did nothing. Well, we did nothing else but keep it standing. And the answer there is you see that very large, those large red lines, that's our maintenance and repair budget. That's replacing that furnace regardless. That's replacing that roof regardless. That's doing work on the facade regardless. The next big numbers that you're going to see are those green lines, which are the energy, like that is the utility cost to run that building. So you can see that both of those take up a very, I mean, there's other costs in there that tend to stay fairly constant, but those make up a very large amount of the operational costs for this building for the next 60 years. We get to compare that to our net zero retrofit scenario. So absolutely, we're adding a brand new cost here, that big blue line right up front. Yes, it is a large investment, but you see that one, we've reduced the size of those those maintenance and repair costs. Yes, they're not gone. You can't think that you're not going to touch this building ever again, but they are severely reduced and they're kind of aggregated. And the second is that you see that we've got a much lower energy cost by a long shot. And that is clearly the biggest impact that this building is going to be having over the next 60 years. So now if we look at this, if we add it all up, so our first scenario, our existing building, which not only emitted 18 tons, but it would have or is costing OCH $2.5 million over the next 60 years. We now compare that to our deep energy retrofit scenario with solar. We now have zero GHG emissions. We've got zero energy effectively, and it's going to cost us about $500,000 less. So about just over $2 million. This is the type of analysis you need to do if you're looking at a long-term strategy. And then I have people that often ask, hey, well, what if I just did the electrification, didn't do the solar? That's that third scenario there. You're going to spend a lot on electricity, even if you make that building efficient, but you don't add the solar. And then that last scenario, we are not the professionals that should be doing this in all honesty, and we can't scale up to 1,000, I mean, personally in terms of our staff. There's probably people that can do it a lot better, and maybe they're even in this room. But let's say that we had a 30% drop in the overall cost of this project. We would now be looking at $1 million of savings over the status quo scenario. And that's real money that we need to realize that the $1 billion that OCH needs to do its retrofit for its entire portfolio is probably hiding in the amount that we're going to spend on it with what we could be saving. Because just if we look at these scenarios, we could be saving somewhere between $2 and $4 billion over the next 60 years. That's where we can go find some of the money in order to actually do these retrofits. But it just takes a little bit of creative financing and some of these tools to do that. So what's next? We've talked about our one little pilot. This is what we need to start tackling. So Britannia Woods, for example, you like 4 units? How about 180 of them in this townhouse complex that we manage? Then we've got, you know, maybe we've got some smaller 40-unit walk-ups like 303 King Edward that we have up top there. We can reach with a telehandler and our siding panels up there. What about when we get to 215 Wurtemberg, 115 units, 15 stories high? How are we going to apply all this fantastic lessons learned to these larger scenarios, right? And that's some of the questions that we're asking ourselves. We're coming up with concept designs for these buildings in order to get them to net zero. But then we're going to need some bigger tools. So now in our deep energy retrofit toolbox, let's talk about the market development side. As we aggregate, as we grow this, the size of the amount of units that we're trying to do, we need to start engaging with the manufacturers so that the products that we're looking for are available in time here and hopefully made locally, because it makes no sense to start sending all this money overseas in order to get products here and then having to service them with, I'm not even sure what. We need them locally manufactured and locally serviced. So we are working with different manufacturers as well as with trade organizations to send those market signals to say, hey, the social housing sector in Ottawa needs this. And we're working with other, when we talk about aggregating demand, we're working with other social housing providers and hopefully other providers or any other building owners in the city to start aggregating our demand, saying, yeah, we need 5,000, and maybe that's not a big enough number for you. But what if I said there's 10,000 because we've got these other people, and then Toronto also needs this, and Windsor also needs this. So it's about, we need to help develop that market and send the signals that say, we need this technology, and there is 100% of business for it here in Ontario, here in Canada. Let's keep those development dollars in Canada is kind of my pitch when it comes to that market development. Then we also come up with these blocks where we say, oh, you know what, maybe we don't even have the capital. And in all honesty, this is new technology, and the ongoing maintenance for this is going to be a headache for me and the labor market. And I'm not even sure if my staff would be able to service this. Absolutely, those can be huge roadblocks, but you still have that building. Well, maybe an energy service contract model can fill that gap. Because if we're not, there are limits to how much capital OCH can go access. And when I look at the transition that needs to line up with the climate change master plan over the next 17 years, we may not be able to secure enough capital to do that. But some of our partners would be able to go and capture something from the Canadian Infrastructure Bank, say, hey, you don't need to put the capital. I've already got the capital. All you need to do is now you're going to become, as opposed to being a natural gas customer, you are going to become my BTU customer. I'm going to install that heat pump the same way that Enbridge used to install piping outside of my house for free. Now they're going to install that heat pump for free, and I become their BTU customer instead of their natural gas customer. They're an energy company. It should be half a dozen of one, six of the other. So we need those types of business models, because that is what's really going to accelerate the deployment of this, especially in context where the building owner cannot access the capital or doesn't have the internal resources to deploy those types of projects. And not only that, it's a perfect business case in order to start from a catalyst market, an anchor client like OCH that says, hey, I only need 5, 10, 15,000 of these deployed, to the private homeowner, the private companies that say, oh, I'm just across the street from OCH. Why don't you come and connect to me as well? And whether that is I know there was discussion about a centralized geothermal loop or something like that, or even air source heat pumps out that hang off of everybody's house. It's kind of the same model. It's just about aggregating enough business so that it makes business sense for somebody to come and move into that market in Ottawa. And that is a look at the different tools that we've kind of developed with our deep energy enrichment. Thank you very much for your attention. Question is, hey, that energy service contract, you described it for the mechanical side. What about the building level? And you are absolutely right. So what I have seen are, we've had conversations on the mechanical side. Everybody would love to do the mechanical. It's nice and juicy. The building envelope side, we have had those conversations. The answer is we will only do it if we can have the whole project. They're willing to come to the table for just the mechanical or the whole project, but when it comes to just the building envelope, I mean, that's the answer, is that there's probably no business there. And in all honesty, when we secure financing, it probably starts to make sense on our point of view, saying we are the asset owner for the next 60 years. We're not divesting of these properties. So us making the investment in the physical asset, that building envelope that's going to stay there, and we have an invested interest in, makes some sense. And then leaving that mechanical piece for something that makes a little bit more business sense, that could be a little transient, maybe has 10, 15 years, and you could actually switch providers eventually. It probably makes more sense there. But yeah, the building envelope on its own, you're going to need to lump in the mechanical as well. The question was, how hard was it to get our own OCH trades? Perfect. So, and I'll now put the caveat, everything below the roof line was OCH trades. Above the roof line, we ended up having, and we did eventually need also a contractor to come fill in some of the gaps. But all of the things that you saw in the video in terms of assembling those panels, that were our trade. Those were our trades. We were lucky enough to have a really great development group that had what I'll call like literally a special ops group, because as we were doing some divesting and things like that, they came in and they were doing carpentry work and that kind of thing. So we had a group that was able to do this, but every time I talked to any other housing provider or any other group, they're like, We do not have that group, and if I can be honest, that group has been dismantled. Like it was a tool for the exact moment because we were doing a lot of divestment and we needed to fix up units, so we kind of had a little general contractor arm. But now that we finished with that and we kind of closed out that group, we don't have access to that pool internally anymore. So the answer to your question is, you know what, it is very hard to have that in your corporation because it is so interesting and specific to the point where we no longer have it to do this work. And yes, it is a very interesting and niche, and we're very lucky to have those fantastic people. And that's the question is, hey, what about EV chargers? What about all of those other emissions? And here's the thing. So we've got 27,000 tons of emissions every year. Our tenants have another 36,000 tons emitted every year from their personal vehicles, from the natural gas they burn in a furnace we own, from their waste that goes on. And so, yes, the answer is we recognize our role in that. We control that infrastructure. A tenant can't buy an EV and run an extension cord from their apartment down to their parking space. We're going to need to play a role in some of that infrastructure, and we are figuring out how to do that. In all honesty, we are hitting some blocks in terms of what does that business model look like. And in fact, it's because it also hits up against other people's jurisdiction, other departments' jurisdictions. And they're like, I'm sorry, that's not my mandate. That's your mandate. I'm like, we're going to need to change some of that approach. Similarly to the city, those emissions are in their modeling that I just described. That 12,000 tons of CO2 that's being emitted by tenant vehicles, that's 10. It's in that model. And who's going to make that transition? Even if they wanted to buy the EV, they don't have a place to reasonably plug it in unless we come up with some kind of partnership. And we look at if we put the boundary condition around our communities rather than around the individual, then we see, oh, we all have a role to play. So yes, and I hope to figure that out. So the question is, how can the city help scale up this type of transition, whether it is to Part 9 or to Part 3 buildings? And the answer that I see is that, and I think the city's doing it, and actually the answer is your very, very realistic speech at the beginning, which is like, here is the targets, like here's where we are and we are not on track, is one of the steps. I think the city kind of has it can be that guiding voice that is reporting back. By the way, we are not there yet. We still need some work to do. Here are some of the sheer numbers of what needs to be done every single year. The next part is hopefully, I imagine, as helping to do that financing piece, but not directly in that, like, if we can get the private building owner to take on that deep energy retrofit, but they have to see. So whether it is helping those ESCO models so that it's zero cost to the homeowner and all they get is their utility bill, so that they don't have to take out a mortgage to do these types of retrofit. Whether it's accessing a PACE program, once again, so that the tenant or the homeowner doesn't need to take out a mortgage in order to do these retrofits, they can pay them off, and the next 50 and 60 years worth of owners can pay off that retrofit using their taxes. Those are the kinds of roles that I see that the city can play. And I think that does scale to the Part 3 buildings as well. The question was, how close are we to actually pulling the trigger on, if there was somebody who was listening right now saying, hey, I'd love to start that business. Are you actually ready to issue me a PO? The answer is pretty much, in that we have these buildings. We have received funding from the CMHC Co-Investment Fund that needs us to deliver 6,000 tons of CO2 savings before 2028 in exchange for this large amount of capital. These are the buildings that we have targeted in order to achieve those deep energy, those CO2 savings. So for example, like Britannia Woods, we are trying to do that exact same thing there in order to, it's some of the capital we need, but it's also the energy, the energy and the GHG savings that we need to deliver on in order to capture that in order to even have that capital. So we are actively in concept designs on all of these buildings that you see here and more, in fact. Now, what we're seeing is that the market is telling us it's going to be more expensive than the funding that you've secured, something that we had a little bit anticipated, but the gap is bigger than we anticipated, than we thought. So now we are looking at some of those extra models, and when we can fill that funding gap, we will be moving forward. But right now we haven't, like literally in the summer, we started getting some of these reports back, Class D estimates that are like, ooh, you are short in terms of actually pulling the trigger because the funding you have isn't actually going to cover the entire cost. So that's why we're trying to reframe some of these as business opportunities, right? So right now, if somebody called us up and said, here is your ESCO model, we'll take care of the $160 million of mechanical for all of these buildings. We say, okay, we found the missing gap, and we can now move forward with doing the building envelope portion and bringing in our ESCO for the mechanical. So yes, because once again, to Janice's point, it was so, like, we have to do, like, we are running out of time. There's now 17 years left in order to hit these targets. OCH has to do 1,600 tons of CO2 reduction every single year to just make that target. And we are also not on, similarly, we're not on target right now.